Let's now have a look at the change of base formula. The change of base formula allows a logarithm to be rewritten as a quotient of logarithms with a different base b. So let's say we have some logarithm, log of base a of x. If this cannot be simplified with the values that a and x are currently, we can turn this term into a fraction of two logarithmic terms. In the numerator, we'll use the original argument x as the argument in the numerator. And we want to choose a new base b that allows this term to be easily simplified. In the denominator, our new argument a is our original base a. And whatever the new base was in the numerator, we want to use in the denominator as well. And you want to choose a base that allows not one, but ideally both terms to be easily simplified. So for example, we are going to walk through the process of simplifying the log of base 8 of 16 to its equivalent value 4/3 algebraically. The examples and practice questions throughout the chapter we'll be solving algebraically. But just so you know, there is a way to use the change of base formula with your calculator, and you'll wind up with the same value. So our original term, a log of base 8 of 16, will be equal to a log of 16 divided by a log of 8. Now, you can use this in a calculator. Remember, when the base is not shown, it is a common log with a base of 10. And when you plug this into your calculator, log of 16 divided by log of 8, you'll wind up with 1.33 or 4/3. So you can take any log with any base, as long as they're both numerical, the argument and the base, and change it into a fraction. The numerator will be a log of the original argument. The denominator will be the log of the original base. And by using the common log, you will wind up with its equivalent value. But let's walk through this question and solve it algebraically. Let's say we were asked to simplify a log of base 8 of 16. So step 1, we want to use the argument 16 as the argument in the numerator with a base of 2. And we are using 2 because this can be raised to an integer value to get us to 16. And if we use it in the denominator, we can get to 8 as well, which is for step 2. We want to use the base 8 as the argument in the denominator with a base of 2. So after we reorganize this logarithmic term, we get a log of base 2 of 16 divided by a log of base 2 of 8. And since both of these terms can be simplified, we want to go ahead and do so. So we want to convert each logarithm to exponential form. So we'll start with the numerator by setting it equal to y, giving us a log of base 2 of 16 is equal to y. And now we can convert this to exponential form by taking our base 2, raising it to a power of y, and setting that equal to the argument 16. And now we have 2 raised to a power of y is equal to 16. We can change 16 to its equivalent value, 2 raised to a power of 4, which allows us to see that y is equal to 4, which means the log of base 2 of 16 is equal to 4. So this term is equivalent to 4. And now we convert the log in the denominator to exponential form. So we set the log of base 2 of 8 equal to y. And now we take our base 2, raise it to a power of y, and set that equal to the argument 8. And with 2 raised to a power of y equal to 8, we can change 8 to its equivalent value, 2 raised to a power of 3, allowing us to see that y is equal to 3, which means the log of base 2 of 8 is equal to 3. So we were able to take the log of base 8 of 16 and change it to a quotient of the log of base 2 of 16 divided by the log of base 2 of 8, which is equal to 4/3. and we chose a new base of 2 since that would allow us to simplify both the numerator and the denominator. And that is how we go about using the change of base formula. Let's now have you try a few practice questions. Simplify question number 1, the log of base 9 of 27. Question number 2, the log of base 4 of 32 raised to a power of 2. And question number 3, the log of base 8 of 128 raised to a power of negative 3x. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We were given a log of base 9 of 27. So we can split this up into 2 new logarithms with a new base of 3, since 3 can be raised to an integer value, and we wind up with 9 and 27. So as a result, step 1, use the argument 27 as the argument in the numerator, as we see here, with a base of 3. And now step 2, we want to use the base 9 as the argument in the denominator, as we see here, with a base of 3. And now we went from a logarithmic term that could not be simplified easily here to a quotient of logarithms that can be simplified here. So now step 3, convert each logarithm to exponential form and then solve for y. So we'll start with the numerator. We'll set it equal to y, giving us a log of base 3 of 27 is equal to y. And we can convert this to exponential form by taking our base 3, raising it to a power of y, and setting that equal to the argument 27. And now with 3 raised to a power of y equal to 27, we can substitute 27 for its equivalent value, 3 to a power of 3. This allows us to see that y is equal to 3, which means the log of base 3 of 27 is equal to 3. So 3 can be placed in the numerator. And now we convert the logarithm in the denominator to exponential form. So we set it equal to y, giving us a log of base 3 of 9 is equal to y. And we convert it to exponential form by taking our base 3, raising it to a power of y, and setting that equal to the argument 9. And now with 3 raised to a power of y is equal to 9, we can take 9 and substitute 3 squared, its equivalent value, allowing us to see that y is equal to 2, which means the log of base 3 of 9 is equal to 2. So we find that the log of base 9 of 27 is equal to the log of base 3 of 27 divided by the log of base 3 of 9, which is equal to 3 over 2, and that is equal to 1.5. So the answer to question number 1 is 1.5. So that is the answer to question number 1. Let's now have a look at question number 2. We were given the log of base 4 of 32 raised to a power of 2. Step 1, use the argument 32 raised to a power of 2 as the argument in the numerator with a base of 2. And we want to use 2 as our new base, since 2 can be raised to an integer power, and we wind up with both 32 and 4. So 2 works as a base for both of these numbers. So step 2, use the base 4 as the argument in the denominator with a base of 2. So we wind up with a log of base 2 of 32 raised to a power of 2 divided by a log of base 2 of 4. And before we convert each logarithm to exponential form, we want to move this exponent 2 to the coefficient here using the power rule. And now we can convert each logarithm to exponential form to help us simplify both of these terms further. So we'll set this logarithm, a log of base 2 of 32, equal to y. And now we take our base 2, raise it to a power of y, and set that equal to the argument 32. So we have 2 raised to a power of y is equal to 32. And 32 is equivalent to 2 raised to a power of 5, allowing us to see that y is equal to 5, which means the log of base 2 of 32 is equal to 5. So this term here is equivalent to 5, giving us 2 times 5 in the numerator, which would be 10. And now this term, a log of base 2 of 4, we set equal to y. We take our base 2, raise it to a power of y, and set that equal to the argument 4. And to solve for y, we swap out 4 for its equivalent value, 2 squared, allowing us to see that y is equal to 2, which means a log of base 2 of 4 is equal to 2. So we can swap 2 in for this term here. So we wind up with 2 times 5 divided by 2, and now we can evaluate this expression. 2 divided by 2 is 1, so those cancel each other out, leaving us with just 5. So we find that the log of base 4 of 32 raised to a power of 2 is equal to 5. That is the answer to question number 2. Let's now have a look at question number 3. We are given the log of base 8 of 128 raised to a power of negative 3x. Step 1, use the argument 128 raised to negative 3x as the argument in the numerator with a base of 2. And we use a base of 2 since that will allow us to get to both 8 and 128. Step 2, we want to use the base 8 as the argument in the denominator with a base of 2. So we have a log of base 2 of 8 in the denominator. And now we want to move this exponent, negative 3x, to the coefficient here using the power rule. So we wind up with negative 3x times a log of base 2 of 128 in the numerator. And now we can convert each logarithm to exponential form. So we'll start with the logarithm in the numerator. We'll set that equal to y, giving us a log of base 2 of 128 is equal to y. And to convert this to exponential form, we take our base 2, raise it to a power of y, and set that equal to the argument 128. 2 raised to a power of y is equal to 128, and 128 is equivalent to 2 raised to a power of 7, allowing us to see that y is equal to 7, which means a log of base 2 of 128 is equal to 7. So we swap this term out here for 7. And now the log in the denominator we set equal to y, giving us a log of base 2 of 8 is equal to y. And now we take our base 2, raise it to a power of y, and set that equal to the argument 8. And 8 is equivalent to 2 raised to a power of 3, allowing us to see that y is equal to 3, which means a log of base 2 of 8 is equal to 3. So we swap this term in the denominator for 3. So we wind up with negative 3x times 7 over 3. And now we can evaluate the expression. Negative 3x times 7 is negative 21x. And negative 21 divided by 3 is negative 7. So we find that a log of base 8 of 128 raised to a power of negative 3x is equal to negative 7x.